Hi, everybody. So you can see me in the bottom right-hand corner of the screen there. Greetings to you from my bed in the guest room where I've spent almost the last 2 weeks recovering from surgery. My apologies if there's some weird background noise. My dogs may bark at any moment, and I hopefully will try not to move the computer very much, but if I do, it may make a terrible background noise, and I apologize in advance for that. But as promised, it's a little late, but I'm hoping that this will help some folks. I wanted to record this video to show you some tips and tricks to help you balance equations involving polyatomic ions. And so you can see here that there is a reaction in front of you that involves a double replacement reaction. And the reason we know it's a double replacement reaction is because both of the reactants, we see here potassium nitrate and calcium phosphate, are they are ionic compounds. And so when we have two ionic compounds that are both dissolved in water, I didn't put in the state symbols, but we can assume that they are. The ions are going to switch places. Potassium is going to join up with phosphate, as we can see here, and calcium is going to join up with nitrate. And so one of those products would have to precipitate. It would have to be a solid that would come out of the solution. But the point of this is to practice balancing the equation. So I'm going to start by filling in our chart here. I'm going to provide you some answer keys to some of the work that we've done over the last few weeks that does not have those charts filled out, but hopefully this will help you remember the process that we follow. So first thing I always like to do, especially when equations are tricky to balance, is to fill in a chart with the number of atoms of each element on each side. Now, the trick here with polyatomic ions is that we can treat those polyatomic ions, as long as they appear on both sides, as their own independent atom. This would be very difficult to balance if we didn't do that, because we have oxygen in so many different places. So I'm going to go ahead and fill in this chart before we start, and I'm going to start with potassium because it's the first thing that we see in the equation. I usually just go left to right here. And so we have one potassium atom on the left, and we see a subscript of 3 here on the right, so we know that there are 3 potassium atoms on the right. Now we're going to count the number of NO3s, the number of nitrate ions. And you can see here that I've highlighted this nitrate ion in yellow to show that we always keep those together. The rules for polyatomic ions are that we must keep that formula intact. And so the way we're going to know how many we have is if there is a subscript on the outside. We can see over here on the left that there is no subscript. There are no parentheses, and anytime we see that for a polyatomic ion, we can assume that there is only one. So what we're saying here is that there's one of this group of atoms, this NO3, this nitrate ion. And on the other side, we can see that there are 2 nitrate ions because we have this group of atoms in parentheses, and we have a subscript of 2 on the outside. So now we go to calcium. We start with 3 calcium atoms on the left because we have the subscript of 3. And over here, we have a subscript of nothing because there is no subscript. Sorry about that. And so we know that there is only 1 calcium atom on the right. And now, finally, we're going to count the number of PO4s, the number of phosphate ions. So we can see over here that we have 2 phosphate ions because we have the PO4 in parentheses and we have a 2 on the outside. Over here, we have just one of that group of atoms, just 1 phosphate ion because it's not in parentheses and we don't have a subscript. So we have 2 on the left and 1 on the right. Okay, so the rule of thumb for me is usually to go left to right when trying to balance the equation. And so we're going to continue adding subscripts, coefficients rather, which are large numbers in front of each substance to balance the equation. And we may as well start with potassium. So we have 1 potassium atom here on the left and 3 on the right. And so to balance the number of potassium atoms, I'm going to go ahead and add a number 3 right here. So when I add that number 3, we're going to need to go into the chart here and change all of the numbers that we need to change. So the 1 changes to a 3, and we also carry that through to the number of nitrate ions. Now we have 3 NO3s. So we're going to change that as well. Now, that does make things weird. It seems like it just made things worse, but at least we were able to balance potassium, and we may need to come back to that later. I don't want to spoil anything. So now we're going to try to balance nitrogen, or the nitrate ion here, but we notice that it's going to be pretty hard to do that because we have a 3 on one side, we have an odd number on one side, and an even number on the other. So whenever this happens, whenever we have an odd number on one side and an even number on the other, my advice is always to make the odd number even. Now, we can't change any of the formulas, but what we can do is change the coefficients. So if we go back to this one here, if we want to make this 3 into a 6, usually the way we make odd numbers even is by doubling whatever number we've put in already. So in this case, we've added a 3, so I'm going to go ahead and make that a 6, and you'll see where this pays off later. So we'll go ahead and make that a 6. We have unbalanced potassium again, and that's okay, because as long as everything balances in the end, we're good to go. And we can see here that now instead of 3, we have 6 nitrate ions. So let's go ahead and try to balance nitrate now. So we have 6 nitrate ions over here, and we have 2 nitrate ions on the right. And so here, we can add a coefficient to make sure we have 6 nitrate ions on the right. And that coefficient basically will answer the question, what times 2 would give us 6? Because again, we have a coefficient of 2 in the formula. And of course, as you know, 3 times 2 equals 6, so we'll add a coefficient of 3 there. So now we've changed the number of nitrate ions to 6, so it looks like once and for all we're balanced there. Hopefully we won't have to change that. And it looks like in the process we have accidentally balanced calcium as well, because we had 1 and now we have a coefficient of 3 in front. Okay, so let's go ahead and move on to phosphate here and see what we need to do to balance that. So the phosphate ion here, we have 2 over here on the left because we have that coefficient of 2, and we have just 1 over here on the right. So that seems like a pretty easy fix. If we need to double the number of phosphate ions on the left, then the easiest way to do that is to add a coefficient of 2. So now we have 2 phosphate ions, 2 times 1. And hey, look at this. I know some of you may have been concerned that I just sort of ignored the potassium problem here, because when we went ahead and fixed the nitrate ions, when we made that odd number even, we went ahead and unbalanced potassium, which I'm sure bothered some of you a bit. But again, trust the process. If you keep moving through and keep balancing one thing at a time, eventually, as long as you have the right formulas, things are going to work out. So in this case, we've added this coefficient of 2, which means we have 2 times 3, or 6, potassium atoms. So that was a roller coaster. That was a wild ride. And part of the reason it was a wild ride is because we did have these polyatomic ions. But by considering these as one single atom instead of separating them out, it does minimize the number of steps you have to follow and ultimately makes the problem easier. So for those of you who have been struggling with polyatomic ions, hopefully this helped you to kind of navigate those slightly harder balancing equations. And I hope it's helpful. Keep plugging away, keep putting in the work. If you trust the process and keep the repetition up and keep putting the work in, you're going to get this stuff. I believe in you. Please reach out if you have any questions, and have a great weekend.